Hello, ladies and gentlemen, welcome back. And I'm absolutely sitting on a couch similar to in the background, but not on a cheap chair. Anyways, let's start with topic of today, that is how a Linux system boots. Before we start, if you are an Arch Linux user, sir, you might already know it. It is for users of other distribution. I'm not saying the users of other distribution doesn't know how a Linux system boot, but the way Arch Linux is installed, it teaches you about those things at the very beginning. So with that, let's start the video, and at the end of this video you will be able to understand your system better and can debug any error if occurred. So yeah, let's start. Let's start from the very beginning. So while installing Linux, you might have seen something similar or maybe something fancier than this, but at its core, it is just a menu which allows you to select the device to boot into. So when you installed your Linux, you might have booted into your USB device or CD to install your Linux system. So this is what is called as a boot menu, where you can select which device to boot. But in a normal scenario, you do not have to always select that which device I want to boot into. That is because BIOS stores a set of boot entries and priority to which device it should boot the operating system from. So that is called boot entry, EFI boot entry. To see that boot entry, either you can go to your BIOS and look at it on your own, but if you are on a Linux system, you can use a command called EFI boot MGR to look at your boot entries. So in my case, I have three boot entries. So first one is Arch Linux, which is the system I'm currently in. So what does this boot entry says to our BIOS? It says that here is an entry called Arch and you have to boot the bootloader. We will come back to what is a bootloader. You have to load the bootloader from this HDD, or maybe I should say SSD, or as a general storage, from this storage which has an ID of this long string 25025 and at the ending 0A. From this partition of this drive, you have to load a EFI file which is grubx64.efi at /efi/arch/grubx64.efi. This is our bootloader. So what is a bootloader now? A bootloader is a program that knows how to boot our system, where is the kernel and file system and how it should start it. So that is a program. So in most of the cases, you will find Grub as a bootloader, but there are other options as well. So now let's sum up. The BIOS knows which boot entry to boot into, and you can see boot priority. I said boot priority is this boot order. So it will try to boot from this first thing 0000, and the second priority is 0001. If I want to switch to 0001, I can change it and move it at the beginning of the list, and by default my KCOS will start. So this is the entry that tells your BIOS where to look for your bootloader. Now when the bootloader is loaded, bootloader is responsible to load our kernel and mount the file system. So the boot entry that you see, for example, boot entry, the similar grub boot entry that you see is displayed after your BIOS has loaded the bootloader. So now when you select these entries, it will start the system. So where does this entry come from? So if you go into, okay, well, before that, I want to show you that the EFI.grub.efi that I showed you in this entry actually exists at pwd /efi/arch linux. This /efi/arch matches with this entry because I have a separate EFI volume that is mounted at /boot/EFI. That is why you see /boot/EFI at the beginning. But if you consider this partition as the root, then you have to go to /EFI/arch and you will find the grub x64 EFI. And this is how it is loaded. So after it is loaded, it will start the grub, and the configuration of grub are stored at /boot/grub. If you ls into this directory, you will find all the things related to grub. So the image that shows the selection menu, this thing is generated from these configurations file that are present at slash boot slash grub. Now this grub.cfg theme, these all defines how it behaves. So the font, the spacing, the orientation, and all of these things which are displayed in the grub boot menu are defined in these files. Now let me open up this grub.cfg file in a code editors to see what is actually present in there. Now you can scroll all of these and directly go to boot menu entries. Now this menu entries is exactly what you see on the entry, boot entry. You see the name Arch Linux is displayed over here, and from where you can select, obviously this is an example image, so it contains Fedora, but in that case it will contain Arch Linux, and when I select this boot entry, it will proceed further. Now at this point, when we select this entry, Arch Linux, then the bootloader, that is grub, will start the system with our kernel and our file system. So when you see at the line 117, you see VM Linux dash Linux, which is our kernel binary. So if I wanna show you where exactly it is located, you will go to slash boot, and when you do ls, you will exactly find your Linux binary at this location. So if I do file VM, you can see it is a binary that is executable, boot executable. So this is the actual kernel, and to that kernel we pass some parameters, which is root UUID. This UUID belongs to the partition of your root file system. So let me show that to you. If I do sudo ls blk blkid, you will see the same UUID present over here. dd19, which is my root, dd19, which is our root. Now before it actually mounts the root file system, it uses an intermediate file system that is called initfs. So this is the initfs. It loads initfs, and initfs is there to do various things. For example, if you want to load any driver which is not already present in the Linux kernel, then the process to load the kernel will be present in the initramfs, and it will load that driver, then it will hand over it to the root file system. Now the root file system is mounted and the system will proceed. Now when Linux system boots, it will look for a specific path in the root file system, which is slash bin slash init. So it is also a binary which is started at the very beginning of the Linux boot process. So the first process with process ID 1 is this init process that is loaded. So if I want to show you, let's say, system monitor, what was the first process that booted while the system started? So let's see if I can rearrange this to PID1. As you can see, systemd. Systemd is an init system. So let me clear that to you. If I do list this thing, you will see it is nothing but a link to actual systemd. Systemd is our init process. We have the link at slash bin slash init because Linux system by default looks at this directory. So we have a link to systemd at this path. So the kernel starts this process systemd, and systemd will later on start every other processes. For example, your GUI system, your background processes, your audio, and everything else. So you can see in a tree-like structure, systemd was the first process that started, and after that all the other things are child process of it. And what automatically to start and not start by systemd is defined by, well, actually our configuration. For example, if I say sudo systemctl status, let's say docker, you see here it is disabled, which means that when systemd will start, it will not start Docker service on its own. If I change this to enable, then when systemd starts, that is when our system start, it will automatically start Docker process in the background. So to summarize up, let's summarize everything up. First thing, your BIOS will look at the boot entries and it will find out where is the bootloader located. It will find the bootloader at the specified place using the entry which was present. Then it starts the bootloader, and bootloader actually tells where is the system kernel and root file system located and to load that. So that is the menu entry that we see. When kernel starts, it loads our root file system and it starts the init process. Now when init process starts, it automatically starts all the other processes as a child process that we see. In this case, the init system is our systemd. So this is how a Linux system boots from BIOS level to all the way to the desktop environment that we see. Hope you enjoyed it and don't forget to subscribe. See you in the next one. Keep watching.